Question 4 asks us to find the inverse of each function. I put the 4-step process that we use to find the inverse of each function. Remember, the key idea behind inverses is that your inputs and your outputs change roles. When we do the inverse, we ask the question in reverse. So we say, if we know what the output was, can we go back and find the input? And that gets us this idea where we switch the roles of x and y. So I'm going to demonstrate or model how we apply these 4 rules. These rules here, the first thing we do is we replace f of x with y. That's more of a convenience package for us so that it's easier to operate on y than it is f of x. So y's are your outputs just as f of x's are, plus 1. Now your second step is to reverse the roles of x and y, and that's what inverses do. So we replace the x's with y's and the y's with x's. I just did step 2. Now this is where your algebra has to kick in. Now we're going to solve for y. So to solve for y, we do our gem-DOS backwards. When we solve the equations, we go backwards through this. So we want to undo the subtraction first. So it's x minus 1 equals a negative 2y. And then we want to divide by a negative 2. So if we divide by negative 2, one way to represent that would be x minus 1 divided by negative 2 equals y. And that represents your inverse function. So now I'm taking care of step number 4. You flip your y back into your inverse. Now there's some alternate forms of this that you might write, and they're equally correct. You can distribute that, the dividing by 2, so you'd have this is a 1 here sitting on x, so I got a negative 1/2 x, then minus a negative is plus 1/2. So this is equivalent to the other one, and I'm not sure which one you would write. Either one is correct. I don't really have a strong preference either way. But all I'm doing is I'm distributing the negative 2. So negative 1/2 x plus 1/2 is equally correct.